Time to learn about similar right triangles. So an altitude is a line segment through the vertex and perpendicular to a line containing the base, the opposite side of the triangle. So all that fancy mumbo jumbo is if I start at B and I drop a line down, that is the altitude and it's perpendicular. Okay, so you have a couple things happening. If you have a 90-degree angle there, you also have one on the other side. So you basically made three right triangles. We had the original ABC triangle. Let's go ahead and call that point D. I have a smaller ABD triangle, and then I have a medium BDC triangle. Now, another cool thing that happens, if you drop that angle down, you're going to have a 60-degree. Now, if you split up angle B, you would have split it up into a 30-degree angle and then a 60-degree angle. Okay? And so you can use your knowledge of a triangle to figure out that this angle is going to be 60, and therefore this angle is going to be 30. Okay? Because in a triangle, 90 plus 30 plus 60 gets you 180. So, by angle, I know that every single one of these triangles are going to be similar. Okay? So if I have this ABC triangle, the big one we started out with, where I had B with the right angle, A was here with 60, and then C was here with 30. If I were to draw a triangle ABD, which is this one right here, if I drew the 90-degree angle up top to match it, that would be point D. The 60-degree angle in that was an A, and then the 30-degree angle was a B. Okay? Now if I draw the other right triangle, which would be this one, I'm going to flip it upside down. For the right angle to be up top, that would be a D. The 60-degree angle was B, and then the 30-degree angle was C. Okay? So I've got all of these triangles that are split up, and turns out they're similar. Okay? So remember, with similarity, I could say this side over this side equals this side over this side. So we're going to be dealing with proportions, and you need to learn this other thing called a geometric mean. So blank is the geometric mean. The geometric mean is a special type of average where you multiply the numbers together and then take the square root of the two numbers. Okay? So we're going to be square rooting numbers. So find the geometric mean of 3 and 4. So you're always going to have x, and they're always going to be diagonal. Okay, to get that, you're going to have x squared equals your a value times your b value. So if they say find the geometric mean, you are going to plug 3 and 4 into the a and the b value. So you could say 3 over x equals x over 4. And then you would multiply and get x squared equals 12. To get rid of the squared, you're going to square root both sides, and I would have x equals the square root of a 12. Now, we could be dealing with decimals, we could be dealing with simplest radical form, which is just why we learned how to simplify square roots. So if it wanted simplest radical form, I would need to simplify that fraction into 2 root 3. Okay? So it's all about the directions and how they want you to phrase it. Okay? All right, so let's take a look at two relationships that form. So one relationship is called altitude hypotenuse. Now, how I remember it, it's side, altitude, altitude, side. Okay, and the sides are going to be dealing with this side of the triangle and this side of the triangle. So there are two different sides of the triangle. So if you are looking for the altitude, or they give you the altitude, which is this red line right here, they drop down, you're going to be using this proportion. So how you would set it up is pick a side, doesn't matter. So I'm going to start with 2. So I'd say 2 over the altitude, which is 7, equals the altitude, which is 7, over the other side, which is x. Okay? So basically, you need each piece of that hypotenuse to do this problem. And then you're going to cross multiply. So I get 7 times 7 is 49, equals 2x, divide by 2, and get x equals 24.5. Okay, so you won't always be square rooting, just in some cases. Okay, all right, on this top right one, you are looking for the altitude, in this case h. So I'm going to be using side altitude, altitude side. Again, you could say altitude side equals side over altitude. It's just up to you however you think about it. So I'm going to try a different way. And I'm going to say the altitude over the side equals the side over the altitude. Okay, it's up to you. But you would get h times h, which is h squared, equals 27. Square root. Now I need to break down this square root over here. 27 is 9 times 3. 9 is a perfect square. So your answer would be 3 root 3 for h. Okay? Again, that's if they want simplest radical form, or you could put decimal if they didn't care. Okay? One more problem with side, altitude, altitude, side. So I know my side, but I am missing this side over here. But good news is I know this is 25, so I could figure out what this piece is by doing 25 minus 9 to get 16. And now I can do my theorem to find the altitude. So I'm going to say side over the altitude equals the altitude over the other side. Okay? Cross multiply. I get x squared equals 144. Square root both sides. What's nice about 144 is it's a perfect square. So x equals 12. Okay? Now, couple other things. Let's say I now know this is 12. Could I find this side if there had been another variable? Yes. Okay. I've got a right triangle, and I have a side now, and I have a side, and that's the hypotenuse, so you could do the Pythagorean theorem. Okay. So basically this is used when you can't do the Pythagorean theorem. Okay, but if you needed to find this side or this side, you would need to do the Pythagorean theorem once you found the altitude. Okay? All right, there's one more relationship that happens when you have an altitude. All right, this one's called hypotenuse-leg. Now, this is obviously when you have the hypotenuse of the bigger triangle. Okay? So if you know the hypotenuse, and we don't really care about the altitude in this case, and you know the leg and a side, that's when you use this theorem. Okay? I will say this means the leg of the bigger triangle, the leg of the bigger triangle, and this is the small side. Okay? So that gets a little bit tricky. So you're dealing with the hypotenuse with the big side, the leg of the big side, and a small side of a smaller triangle. So the hypotenuse in this first one is 13. Now the leg of the big triangle. Here is your big triangle. The leg is a 5. I'm going to repeat that 5 up here over a small side that is in the same side as the 5. So for example, I couldn't find this side over here. So hypotenuse, side, side, other side closest to it, which is x. Okay. Now again, I know this is hard. It's going to take some practice, and we will get plenty of it. But you will get 25 equals 13x. Divide by 13, and you should get 1.9. Okay. All right. Let's take a look at this top right one. Again, I know the hypotenuse, or I'm looking for it, so I'm going to use this theorem. And so I'm going to say hypotenuse over the leg of the bigger triangle, which is this whole thing, equals the leg over the side closest to it, which is 33. Okay, cross multiply again. 36 times 36 is 1,296 equals 33x. Divide by 33. And you should get maybe 79.3. Okay. All right. So those are the two theorems that happen when you have an altitude in a right triangle. Now let's look at how they could make them harder. So when you look at these, they look harder because there is a square root in them. But do not freak out because we're going to get whole numbers, and I'll show you. All right, so first off, you got to figure out which one you're going to use. Now, I'm looking for the hypotenuse, so I'm going to use the one I just learned, the hypotenuse-leg, leg side. Okay, so the hypotenuse is 6. The big leg is 7 square root of 3, 33. So it's going to repeat on the top over the side closest to it, which is a 33. Now, we learned that if you multiply a square root by itself, you just get that number. So that's true. So if I multiply square root of 33 times square root of 33, I'm going to get the same thing. So let me show you what happens in the calculator. So I want to cross multiply these two terms. So I want to say 7 square root of 33, and I want to multiply that by 7 square root of 33. Okay, I got 1,617. So all that happened was the square root of 33 times the square root of 33 is a 33. And then they did 7 times 7, which is a 49, and you get the same thing. So that's what's happening in your calculator when you multiply those two numbers. All right, let me continue. So when we cross multiply, we got 33x equals 1,617 divided by 33, and you get 49. Okay, so that problem looked harder because it had a square root in it, but it ended up multiplying itself out. Okay, all right. Second one, figure out which one to use. They gave me the altitude, and so I'm going to be using that first one, which I just forgot. Side, altitude, altitude, side. So one of the sides is an x over the altitude of a 6 root 13. 6 root 13 repeats. Side, altitude, altitude, the other side, 13. So again, I'm going to get 13x. Now, in your calculator, square root of 13 times square root of 13 is a 13. So you're going to do 13 times 6 times 6 to get 468. Divide by 13, and you would get 36. Okay? So again, these look harder because they have a square root, but once you figure out which relationship to use and then solve it, it's not so bad. Okay? All right. Why don't you try the next two on your own? You will get a decimal for this right one, so go ahead and simplify that, and you can use a decimal. So press pause and try those. There are two answers. On the left one, you were looking for the altitude, so you were going to use altitude, side, side, altitude. So they gave you a little bit of unnecessary information. I didn't need that 9, okay? So that's how you would have gotten 8.1. Now another way, is this a right triangle? Yes. Could you have done the Pythagorean theorem? Yes. So you could have said x squared plus 5 squared equals 9 squared and solve for x, and you would have gotten the same exact thing. Okay? Same thing on this right side, we had a little bit of unnecessary information. So what I did was I knew the hypotenuse was 92 since this was the leg of a triangle. So I had to use that second one, hypotenuse, leg, leg, side. So I did the hypotenuse over the leg equals the leg over the closest side. So again, I did not need that 144 right now. Okay, so that's one way of doing that problem. Now you could have done some more work to find the altitude, and then you could have done the Pythagorean theorem. So you could have said altitude, side, side, altitude, and you could have gotten a number for there, and then you could have done the Pythagorean theorem to find the hypotenuse, kind of up to you. But the quickest way is to use that hypotenuse-leg theorem. Okay? All right. So those are how you do those problems. Now if you want to watch the second video, it's on some challenge problems. But if you think you're comfortable or don't want a challenge, thank you for watching and you can practice. Alright, thanks for tuning in to part 2 with the challenge problems. Again, you're going to try these on your own. So I want you to go ahead and try all of these. Solve for x in these two, and then find all the missing variables down here. So press pause, and then we will go over them. So for these challenge problems, you should have gotten 16 and 100 for the first two. You could have done either method that you liked best. So if you liked hypotenuse, leg, leg, side, you would have had to know the hypotenuse was x plus 9. And then the side was 15, 15 over 9. And remember, when you multiply, you're going to have to do 9 times x and 9 times 9. Now, if you wanted to do side, angle, angle, or side, altitude, altitude, side, you would have had to find the altitude, which is pretty easy because you've got a right triangle. You could have done the Pythagorean theorem to find the altitude. And then you could have used the side of the altitude, altitude of the side. Now, either way, same work. Pick which way works best for you. Same thing over here. If you wanted to do side altitude, altitude, side, you would have had to find a representation for this missing piece, which would be x subtract 64. And you could have done it that way. Or you could have known that you had the hypotenuse, but you would have needed this side over here. So again, you know this is 64 and this is 48, so do the Pythagorean theorem to find this missing side, and then you could have done hypotenuse, leg, leg, side. It's up to you, but you would have gotten 100 no matter which way you did. Down here, I solved for A first. You could have solved for B first, but I did the hypotenuse, side, side over A. You could have done 5 over 3 equals 3 over B, but once I got A was 3.2, I just subtracted 5. And then I did, for the altitude, I did side, altitude, altitude, side. You could have done Pythagorean theorem. It's up to you. Over here, I found x first. Again, you could have found y first by doing hypotenuse, leg, leg, side, or hypotenuse, leg, leg, side. And then for z, I did the Pythagorean theorem, but you also could have done the altitude, side, side, altitude, using x and y to find z. Again, up to you which way you prefer, but those are how you do the challenge problems. Okay, so let me know if you have any questions on that. Otherwise, you're a rock star.